basically zip through numbers and improper fractions going back and forth. You probably even have this exact page, but we're going to do it again. A proper fraction is where the numerator is less than the denominator. Can't spell today. Denominator. Okay, it's a correct fraction. Okay, we're working in that big packet that I gave you the other day. An improper fraction is when the numerator is greater than the denominator. It's not a proper fraction. Improper. A proper fraction, by the way, is less than 1. Right? Anything where the top is smaller than the bottom is less than 1. 1 whole would be when the top is the same as the bottom. And the improper fraction is greater than 1. It looks like a 1. Anytime the numerator is bigger than the denominator, or, well, it's greater than 1. If the numerator is equal to the denominator, it's worth 1, right? 3 over 3, 4 over 4 is worth 1. And a mixed number is essentially a whole number plus a proper fraction. Technically, it is adding the two together. So if you look like at the example, now let me put a different example up here. 2 1/4 is the same as 2 plus 1/4. 2 whole whatevers, 2 whole pizzas plus 1/4 of a third pizza. 2 plus 1/4. I always think pizza when I think fractions. Makes me hungry. You need to scooch one way or the other. You can, Alex, if that'll help. I know Logan's kind of tall. Better? Okay? Basically, what you need to be able to do is fluidly, which means easily, without any trouble, go back and forth between mixed numbers and improper fractions. Okay? Because to do a lot of math with fractions, you need to make them into improper fractions. Multiplying and dividing, you have to make improper fractions. I'm going to show you a way to do adding and subtracting with improper fractions this year, which kind of takes some of the issues out of the borrowing. So you need to be able to go back and forth, because if you know, we talked yesterday about final answers of fractions need to be in simplest form. A improper fraction is not simplest form. So if you get an improper fraction as your answer, you need to simplify it, which would include making it into a mixed number. All right? So, writing a mixed number as an improper fraction. The example, we're going to go right on to the right, and like I said, you probably have this exact same page from last year. Write 6 2/3 as an improper fraction. Step 1. Multiply the whole number by the denominator. Because if you think about it, the denominator is how many parts the whole is divided into. So like in the case of my example, I have pizzas divided into thirds, 6 whole pizzas. If each of them is into thirds, I would have 6 times that group of 3. So in the case of my mixed number, I would do 6 times 3 would be 18. So that means, like, if, again, going back to my pizza, 6 whole pizzas divided into 3 pieces per pizza, I have 18 pieces, not counting the 2/3 left. Okay, that's just the whole pizzas. So far, so good? Hopefully this is coming back to you. Step 2, add the numerator. Think of it again as pizzas. We had 18 slices from the whole pizzas, plus we had that one pizza that we only had 2 slices left out of 3. So we've got to add that to my pile if I want the total pieces. So I had my 6 2/3. I multiplied. Then I add. So I had 6 times 3 equals 18. And then I add my numerator. So I have 18 plus 2 equals 20. So if we're, again, talking pizzas, I have, with 6 whole pizzas and another pizza that's 2/3 left, I have 20 pieces. I have 18 from the 6 whole plus the 2 more. Okay? Make sense? Then the last step is going to be to write it as an improper fraction using the same denominator. So I'm going to take that 20, that number that I got, and that's going to be my numerator because I have 20 pieces, right? Out of, or over 3, because each one is divided into 3. So I have 20 thirds, because each piece is a third of a pizza. So I have 20 pieces. There's 20 thirds. Okay? Now you would need this to multiply. You have to multiply and divide. I know we talked last year about it. You have to make them into mixed or improper fractions. You cannot multiply and divide in a mixed number. You can't do it. You have to change to improper fraction first. And I know when we added and subtracted, especially subtracting, and we had to borrow, it kind of got a little confusing. So I'm going to go back, and if you remember, I kind of showed you how to borrow. I'm going to go back and show you how to do it this way, which I think will be just maybe make a little more sense, less margin for error. Let's do like a couple really quick examples on the bottom, just to make sure that you're with me here. If I have 4 and 7/9, okay, I have a cake divided into 9 parts. I have 4 cakes. Well, technically I have 5 cakes. I have 4 whole cakes and then a 5th cake that has 2 pieces missing. Right? That's what this is saying. Correct? So how many ninths do I have? If I were to chunk it all up and pass it out in plates, basically, and each plate has 1/9 on it, how many plates am I going to pass out? Jenna? That's the 9 plus times 4. And then you have to add that's the whole cakes, but don't forget I have 7 left from that other cake. So I add to it and I get what, Claire? 43. So altogether I have 43 ninths. So if this were my cake, I could have 43 little plates to pass out, and each piece is 1/9 of a whole cake. Alex? Yes, you always do your whole number times your denominator. Okay, and then add the numerator. Correct. Yep. All right, let's do one more. How about 6 and 5/7? Because think of the whole number as it's a whole, and if I were to do the one whole, each whole would be 9/9, right? Because that means 1. So 4 of them is 4 times 9 in that case. So in this case, my whole is 7/7, and if I have 6 of them, I'm going to do 6 bunches of 7. 6 times 7 is 42. And then I have those 5 left over on the side, so that makes 47/7. Now this is a place where you're not going to simplify when you're done, because basically if you simplified this, you'd be back where you started from. And the whole point of this is like to go backward. You're unsimplifying, you're making it complicated to do your math, and then you'll simplify again when you're done. Mark. I'm going to teach that in 1 second. We're going to take an improper fraction and make it into a mixed number, because when we're done, you have to have simplest form. So this would be basically saying I'm making it into simplest form. So step 1, think about it. If we multiplied before, what are we going to do this time? Divide. Question, Jenna? Oh, I just got it. Thank you. Divide the numerator by the denominator with a remainder in the answer. This is one of the few times when you're still going to get to do the remainder. Remember that a fraction is essentially a division problem. That is really 9 divided by 6. That's what this is. Because you're saying, I have 9 things, and I'm going to put them in groups of 6. How many 6s go into my 9? Well, 1, with a remainder of 3. Yep. Think to because basically what you're doing is you're whatever your whole, it's divide. Think about, again, your pizzas. I got pizzas cut into 6 parts, a bunch of them. I got 9 parts, and I need to put them back together and say, well, how many whole pizzas do I have? Well, 6 of those make a whole pizza. So how many chunks of 6 do I have? I have 1 whole chunk with 3 pieces left over in this particular example. Okay? Step 2. The quotient, which is the answer to a division, which you need to know, is our whole number. Remember, a mixed number has a whole number plus a fraction. So the quotient, this 1 right here, becomes my whole number. Basically saying I have so-and-so many wholes. 9 it can be done, divided out into 1 whole with 3 left over. Then, step 3, whoops, that won't work if I have that in my hand. The remainder is the numerator of the fraction. Because think about that. I have 1 whole, and I had 3 left over. 3 what? It was 6s, right? Yeah. No. Yeah. 3 6s. I have 1 whole pizza with 3 pieces that are each piece is worth a 6 left over. Now, if you look at that fraction, I bet you can figure out what step 4 is, because what is wrong with that fraction, Nariah? It needs to be simplified. Do we leave it as 3/6? No, because there's something that you can divide 3 and 6 by, which is what, Nick? 3. So that becomes 1 and 1/2. So the last step is be sure that the fraction is in simplest form. And don't forget the whole number on your final answer. I see that happen a lot. They get done, they simplify the answer, and then when you recopy it, you forget to transfer that whole number, and that makes your answer wrong. Okay, the answer is not 1/2, it's 1 and 1/2. So if you were to write 1 3/6 equals, and then you just put 1/2 because that's what you traded the 3/6 out as, you have forgotten your whole. It's like forgetting a whole pizza. I want pizza for lunch now. I know, you're right, it's not Friday. I might have to make it for dinner or buy it for dinner. Maybe.
Well, I didn't say pizza.
Lucky you. All right, let's do a couple examples. Not today. How about 12 fifths? We'll go with that. Now, some of these, like this, a lot of you could do this in your head without any trouble. I can live with that. But if it gets more complicated, you better be going off to the side or on a piece of scrap paper somewhere and doing your little problem. Or if it doesn't come easy for you in your head, please use the opportunity to use the piece of scrap paper. Because this is a chance to, these are those little mistakes that we don't want to make. Okay? You guys, all of us know that 5 goes into 12 twice, because 5 times 2 is 10. But if you're not sure, or obviously if it's a more complicated number, do it this way. It takes 2 seconds, and it ensures that you don't make a simple, careless mistake. It goes in twice. It has a remainder of 2, so there's 2 left over, so it becomes 2 and 2 fifths. Check our fraction. Can we go any simpler? No, so we're done. How about 46 thirds? I have no idea how that's going to come out. Here's one where most of you probably should be just doing the math really quickly to make sure. Oops, I didn't do so hot on that one. I want one that I can reduce. It ends up being 15 and 1/3. Oh, I should have known that. Not enough coffee yet today. All right, let me find one that I can reduce. How about this one? 52. 52 over, was it 42? No, I can't remember. 24. Now, there's also something else you could do. Do I necessarily have to do my division first? Could I reduce it first? I could, instead of doing the division, well, if I'm doing the division, it goes in twice, right? 2 times 24 is 48, so 52 minus 48 is 4, equals 2 and a 6. Or, either way, what if I said, well, let's see.
I can do 9. You can redo that. Wait, what?
Okay, all right, let me go back. I have 52 over 24, okay? 52 divided by 24 is 2, right? Because 2 times 24 is 48, with 4 left over. Everybody with me there? So it's 2 and 4 24ths, which then I said, well, I can divide them both by 4. So I end up with 2 and 1/6. Good. Okay, you see where I'm at with that? Or, basically what I'm trying to show you is you can reduce first. Yeah, basically you're simplifying it. I could say, well, let's see, that's 26 over 12, right, because that's half. Oh, I could do that again, 13 over 6. So I could have done it by 4, right? Which is 2 and 1/6, because 6 goes into 13 twice. 2 times 6 is 12, so that leaves 1 left over. So I got the same answer. Which one was really the easier division? The 13 over 6 was the easier division, right? I mean, that wasn't that difficult, but what I'm saying is, my point to this is, if you want to reduce first, before you divide out and make it into a mixed number, that's okay. If it's easier for you, still make sure you double check when you get done. If it's easier for you to do the division out first and then reduce, that's okay too. Because your ultimate goal is the answer in simplest form. Either way you do it. We understand, kinda? Kinda, sorta? Kinda, sorta. Yes. Because basically think about what you're doing as taking a whole bunch of pieces of something and grouping them into whatever your denominator is. I have 52 pieces of something where the groups are 24. Okay? Think about maybe I have packages of cookies and I'm packaging them up in 24s, which is 2 dozen, right? Because a dozen is 12. How many, and I've made 54 cookies, and I want to give people packages of 24. How many 24s, how many complete packages can I make out of 52 cookies? I can make 2 complete packages, and I'm going to have 4 cookies left over to eat myself. Does that kind of make it make a little more sense in a way? No. You don't stand between me and my cookies. But does that what you're doing is making it as simple as possible. So this is like putting your answer in simplest form when you're done. Okay? A lot of blank stares.